Hello everyone and welcome back to this channel. In today's video, I'm going to show you how to solve this projectile motion problem. Let's look at the problem. A stunt performer jumps horizontally off a 50-meter high cliff with a speed of 8 meters per second. We are going to find how long does it take to hit the ground, how far from the base of the cliff does the performer land, and finally and most importantly, what is the impact velocity, that is the magnitude and direction of this impact velocity with which the stunt performer hits the ground. Will he survive it? Let's find out. To solve this problem, first, we have to categorize this problem under projectile motion. A projectile is any object that is given an initial speed and then allowed to fall freely under gravitational pull. In this case, a projectile motion is going to have two dimensions of its motion, or two components of the motion. The first one is the horizontal part of the motion, and the second one is going to be the vertical part of the motion. So this problem also has two parts, horizontal and vertical part of the motion. So let's look at the solution. I'll start by drawing the cliff. So we have a cliff. This is the ground. And then I have the stunt performer jumping off this cliff with an initial speed of 8 meters per second. So that speed is horizontal. So he's going to go horizontally with a speed v0 x equals 8 meters per second. However, as this stunt performer moves horizontally, he's going to fall vertically. And in that case, we know the trajectory is going to be a parabola. With this known, we also know that the vertical height, that is the height of the cliff, is 50 meters. Now, what is the range? So we need to find the range of this cliff. So the range is that. One important thing we need to note is that acceleration of free fall g, which is given to us as 9.8 meters per second squared, acts downwards. All right. So for the vertical component of this motion, the object or this stunt performer is going to fall vertically with his speed increasing until he hits the ground. Also, he's going to travel horizontally through this range at a constant speed of 8 meters per second because acceleration of free fall does not affect the horizontal part of this motion. And this is the most important thing we need to note. Another important thing to note is that it takes the same time for both the vertical and the horizontal component of the motion to be completed. So at this point, which will be the final point of the motion, the time taken for this stunt performer to fall vertically would be the same as the time it took him to travel this horizontal range. With this known, we can solve the first part of this problem by finding the fall time. Okay, so the fall time, which is t, can be found using one of the kinematics equation of motion of an object under acceleration. Okay, in this case, we have delta y equals, so this is the first part of the problem. So we have delta y equals 1/2 gt squared plus v naught y t. v naught y meaning the initial vertical speed of this stunt performer. And in this case, vertically, the speed v naught y is 0 because the problem says horizontally off a 50-meter high cliff with a speed of 8 meters per second. So there's no vertical component of speed. So that is 0. So that simplifies to v naught y equals 0. So that takes this term to 0. So we will be left with delta y, in this case, the vertical height, h, is equal to 1/2 gt squared. So to find t, we can multiply both sides of the equation by 2. So from h equals 1/2 gt squared, we multiply here by 2. We do same here by 2. So this 2 cancels that 2. And then we are left with 2h equals gt squared. And now we want to isolate t. So we divide both sides of the equation by g. That cancels this g, and we have t isolated as t squared equals 2h over g. Now t is going to be square root of 2h over g. We can find time, that is the fall time, as t equals square root of 2 times 50, which is our h, divided by g, which is 9.8. And this is going to give us about 3.19 seconds. So the first part of this problem is solved because it says we should find how long does it take to hit the ground. How long does it take this stunt performer to hit the ground? And we just found out that it is going to take him 3.19 seconds to hit the ground. Interesting. Now, for the second part of this problem, we have to find how far from the base of the cliff does the performer land. So let's do that. So B, how far from the base? So in this case, we are interested in finding the range. From first principles, we know that the velocity is equal to distance divided by time, right? In this case, the range, as I mentioned before, because acceleration of free fall does not affect the horizontal component of this motion, the horizontal velocity remains constant throughout the motion. So that horizontal velocity can be our velocity here, and then the distance, which would be the range, divided by the fall time, because again, I mentioned it takes the same time for both the vertical and the horizontal component of the motion. So here we can say our v naught x, which remains constant, equals the range divided by the time. So the range can be calculated as v naught x times the time. v naught x being 8 meters per second. The time, which we just calculated to be 3.19 seconds, therefore gives us a range of 25.6 meters. That's quite a range. All right, now let's look at the last and final part of this problem. Here we are to find the impact velocity, and in this case, the magnitude and the direction of the velocity. So to do this, I'll draw again the cliff. We need to look at what is going on. So we have the cliff, we have the ground here, and then we have our stunt performer jumping off this cliff horizontally. So with some horizontal speed of v naught x equals 8 meters per second. We know because of gravitational pull, after jumping, he is going to fall vertically, and this gives a parabolic trajectory to this motion. So we have that. Now, we are interested in finding the speed at this point, the impact speed. All right, so the impact speed at this point will be composed of the horizontal speed, Vx, some vertical speed, Vy, and then the magnitude of that speed, which is V. And this makes an angle of theta with the horizontal. Okay, that determines the direction. So first we are going to find the magnitude of V and then the direction. And remember, the direction is always taken with respect to the horizontal axis, in this case, Vx. All right. So to do this, we can see that we have a vector, two vectors, Vx, Vy, that we need to sum them using addition of vectors. All right. So we already know that G does not affect the horizontal component of the motion. So our Vx remains constant throughout the motion. So that becomes V naught x, which remains as 8 meters per second. All right. Also, for the vertical speed, we can calculate that using one of these two kinematics equations, because we have both information t, the fall time, we also have h, the height of the cliff. So to do this, in the first case, we can use Vy equals V naught y, that's the initial vertical speed, plus gt. So we know g to be 9.8, we know t to be 3.19 seconds as we calculated from previous slide. Or we can use Vy squared to be equal to V naught y squared plus 2gh. All right. So any of these can be used because we know both t and h. So to do this, I'll go with the first one, okay, using the time we calculated, the fall time we calculated from the previous slide. So in this case, I have Vy equals V naught y plus gt. Now V naught y is 0 because initially we saw that the vertical component of the speed V naught y is 0. Okay, so that sets this equation Vy to be gt equals 9.8 meters per second times 3.19 seconds. So our Vy is going to be equal to 31.3 meters per second. So that is our Vy. Now we can calculate, since we know Vx, we know Vy, we can calculate our V using Pythagorean theorem, because you can form a right triangle from here. All right, so Vx squared plus Vy squared equals V squared. So we can find that using V equals square root of Vx squared plus Vy squared. And that is going to give us square root of 8 squared plus 31.3 also squared. So our V is going to be about 32.3 meters per second. So that is the magnitude of the velocity with which this stunt performer is going to hit the ground, which I don't think I will survive, and he will not survive that impact velocity. Now let's look at the direction. So the direction, we can calculate that using tan theta, the tangent of the angle, which is equal to the opposite, which is Vy divided by Vx. In this case, we have Vy to be 31.3 divided by Vx, which is 8. Okay, so if you do theta, would be the tan inverse of 31.3 divided by 8. Now, can you calculate this and comment it down below? Great. I'll respond to your answers in the comment section. Let me know what is the direction of this impact velocity. And also let me know what you think about this video. And if this is your first time coming to this channel and you found this very useful, please subscribe, like, and share so we can have a maximum reach. Until then, I'll see you in my next video. Thank you.